Hello everyone. So I'll be starting with the new program, that is the convolution of two functions. Today we'll be performing convolution of square wave and exponential function. So let's introduce the text part first. We'll move it upside of this code, and what we are performing convolution of two functions, right? So let's start with the code. Obviously the same two libraries we have to call: import numpy as np, all right, and import matplotlib dot pyplot as plt. Okay, let's run these two commands, and in the meantime we'll introduce more code. All right, so it is going well. So let's start with the same way start in same way. We'll first define the functions. Square underscore wave, let's say, and in brackets we'll write t, and then it should return np. Obviously you have to write np here. Np dot obviously we'll have to apply some condition, where in brackets we'll mention t if t is divided by 1 and this division is less than 1, say, then it will return a value 1, otherwise it will return a value -1. Okay, then we'll define another function. See, it is this programming part is indent sensitive also. Okay, if you are defining something, you'll have to define from very start only. Okay, don't put unnecessary indents there. So we'll define now the exponential function. Exponential, in brackets we'll write t. Okay, and sorry, I should put this, and return, it should return np dot, we know it's a predefined function there, xp. Either we can take it minus t or t, let it be whatever way you want it to be. Let's run these two. Okay, in next step we'll define the length of the sequence as well as the samples. So let's write it: t equals np dot lin space brackets. We are assuming the same length of the that function from -5 to 5, and this time let's say the samples are 1000. All right, and let's say we have defined y1, one variable, which is actually we're calling that square wave from our definition above, in brackets t. Let's say y2 is equal to exponential function, in brackets t. Now as we have called these two functions, we need to convolve these two, right? So let's say we are defining one more variable y, which is convolution of these two. So we'll call this convolution function from our numpy library, con volve, brackets will write y1 comma y2 comma mode equal to full, and bracket close. Done. Now now in next line, obviously we have to define the time axis length of that convolution function. So we'll write t convolution equal to that too will be calling from our numpy library, np dot we'll write it linspace. Okay, let's say it is ranging from -10 to 10, and its sample length will be length of y itself. All right, bracket close. Now it's time to plot the signals. So we'll start with plt dot rc pams params square brackets inverted commas figure figure dot fig size bracket close and equal to, we are defining the image size which should appear on at the output window. Okay, so it will be 20 by 10. Otherwise you'll see some small images and that too will be overlapping type. Okay, now we'll define plot dot subplot. Okay, we are dividing a complete window into subplots. It will be 2 comma 3 comma 1. All right, so at first position we'll be having our square wave, right? plt dot plot in brackets we'll write t. We are plotting t versus y1. Obviously y1 you can see is the square function. Okay, so t comma y1, and if you want to label it something, so you can label it label equal to square wave. All right, so comma close bracket close, and plot dot legend parenthesis, right? So this will display the square wave, square function only. Okay, then we'll display the exponential functions. For that we'll write the same code, subplot 2 comma 3 comma 2 this time, position second. At position second we'll be seeing this exponential function, plot dot plt dot plot in brackets. We are plotting t versus y2 is our exponential function, and label we can give it some label equal to exponential. All right, bracket close, and obviously we want some legend to appear in the plot. Okay, sorry, is there some mistake? No, that's correct. All right, then third one is let's copy this from here. It's almost similar. So at third position we'll be having our third plot, and it will be t underscore convolution with respect to y, and its level will be square wave, square underscore wave convolving with exponential wave. All right, and lastly we'll have plot show to display the plots. Let us run this code. So these are the three plots. The very first one is the square wave. Second one is the exponential, decaying exponential, you can see, and if we convolve these two, something like this will appear. All right, we can change its shape by just changing the polarity of exponential function. See, the graph actually just you'll see 180-degree shift in the final graph. Okay, so this way we can perform the convolution, right? This time I've taken this condition to be if t divided by 2 is less than 1. If I consider it to be t divided by 2 less than 1, then we will be having more number of repetitions in here. All right, so this will be convolution thing appearing at the final end. Okay, so likewise we can perform this convolution for different functions. Like if I take one example, let's say we'll define one function f of t, and sorry, and it should return a value, suppose t cube. All right, and let's define another function, uh, g of t, and it is nothing but exponential function again. So let's run this thing. All right, so I'll be performing this convolution in a similar way. So let's enter some commands in here. Your t, in place of t, will write something different. Let's say it is x equal to np dot lin space. It will range from -5 to 5 again, and in similar way we'll be considering 1000 samples, suppose, so that your y1, I'm calling from above definitions again, f of t, and y2 I think I've already defined. Let's consider some different variables. Let's say z1 and z2 are g of t. Okay, now you know what we are supposed to perform. We have to calculate the convolution of this thing. So we'll write this variable q equals np dot convolve. What variables we have considered? z1 comma z2 comma mode full, mode equal to full, bracket closed. All right, now obviously we have to define the time axis for this convolution function. So we'll write t1 underscore conv equal to np dot lin space. Again I'll consider the same range from -10 to 10, and it will be length q. All right, it will be length q. Okay, now it's time to plot this. We'll start from here. Okay, just copy this thing, control C. Again we'll be having 3 plots. Enter, control V, enter, control V. So 3, in this place we'll write 4, this place we'll write 5, this place we'll write 6, and so we have to change the variables in this place. So I think we'll change this y1 to z1, and its label will be some random function. I'll write t cube. Okay, and in this place we'll write z2, and what this function is, exponential function, I think, exponential function. And at last place we'll be having the convolution thing. So we'll be plotting against t1. I think we have considered t1 underscore conv, and another variable is q. So I'll replace it with q, and this is our convolution function, convolve function, right? T convolve with g t. So let's see what happens. So I can see, right, this is our t cube, and this was our exponential function, and this is what we are getting after convolution. So 2 different convolutions we have seen in a single code. All right, so I think you have got a sufficient idea. So we'll be discussing more functions in upcoming videos. So this is all for now. Thank you and have a nice day.